Eta Carina is the most massive star within 10,000 light-years. In the mid-19th century, a tremendous eruption hurled enough gas into space to make at least 10 copies of the Sun, creating an expanding nebula still visible today. New results from NASA satellites, ground-based telescopes, and theoretical models are providing astronomers with an improved understanding of the system. At the nebula's heart lie two giant stars. The smaller of the two is 30 times the mass of the Sun and 1,000,000 times brighter. The primary weighs 90 suns and shines 5 times brighter than its companion. Both stars produce powerful outflows called stellar winds, but the primary is so dense it prevents astronomers from directly observing the star. The secondary's orbit is among the most eccentric known. Every 5.5 years, when the two stars swing toward closest approach, or periastron, they come about as close to each other as Mars is from the Sun. Eta Carina's most recent periastron occurred in August 2014, and many of NASA's space-based telescopes, as well as ground-based observatories, looked on. Where the stellar winds collide, temperatures reach hundreds of millions of degrees, hot enough to emit X-rays. But the X-ray emission shuts down near the secondary passes through the thickest part of the primary's wind. The gas relaxes, settling into a lower energy state. As a result, the crab appears in a different spectral line until the stars move apart and the UV light is restored. Eta Carina is one of the closest and most massive colliding wind binaries, and serves as a natural laboratory for studying these rare and important objects. While its past eruptions remain unexplained, astronomers think they have a handle on its current state, a claim to be tested at the next periastron in February 2020.